Hello students, I welcome you all to this video session on Poynting's theorem. This will be asked for maximum of 10 marks in your university exam. Poynting's vector or Poynting's theorem. So basically, Poynting's theorem is the theorem or which establishes the relationship between the power, electric field and magnetic field. So basically, the power flow in any medium, I'm talking about electromagnetic waves flowing in any medium, and the power flow in any medium can be obtained using Poynting's theorem. Actually, you can finally see the relationship between power, which is equal to E into H or E cross H. Now, this is the Poynting's vector. And usually you will be asked a question like from Ampere circuital law, derive Poynting's vector or Poynting's theorem. So from Ampere circuital law or modified Ampere circuital law, we know that del cross H is equal to conduction current density plus displacement current density. So this del cross H is given by del cross H is equal to sigma E plus dou D by dou T. This is displacement of flux density. But we know that D is equal to epsilon E. Therefore, we could write this del cross H equation as del cross H is equal to sigma E plus epsilon dou E by dou T. So basically, we are here to extract the relationship between E cross H, which is actually a power. So we want this E cross H relationship, but we have del cross H here. So we will take the scalar product of E on both the sides. Okay, if we take the scalar product of E on both the sides. So here take means multiply both the sides by E, taking scalar product of E, right? Scalar product of E on both the sides. Why? Because logically speaking, I am trying to obtain the relationship between E and H, but I have del cross H here, so I'll introduce E here, or else you could say, yeah. So, or else you could say that you can take this E common factor, but here you have the differential element, so I cannot take it out. So we'll take the scalar product of E here. So I'll get E dot del cross H, E dot del cross H is equal to sigma E square plus epsilon E into dou E by dou T. I'll call this as equation 1. Okay. So, but what we are interested in, I'm just writing this statement so in order to specify in the exam, but we want E cross H. We want any equation in the form of E cross H. So let us just try to get the vector identity of this E delta cross H. So applying vector identity or using vector identity, I can write del of E cross H is equal to H del cross E minus E of del cross H. Therefore, E of del cross H is equal to, therefore, E of del cross H is equal to H del cross E. So this will go to the right hand side minus del of E cross H. Therefore, equation 1 becomes, so I'll substitute this E of del cross H. Therefore, equation 1 becomes H del cross E minus del E cross H, which is equal to sigma E square plus epsilon E dou E by dou T. All this as equation number 2. So now we have this form of E cross H, which was our objective. Now to find H of del cross E. So now I want to find, this is an unknown variable. To find H del cross E, del cross E, we know that del cross E is equal to what? As per your Faraday's lens law, del cross E is equal to minus dou B by dou T, which is equal to minus mu dou H by dou T. Because B is equal to mu H. Now I'll take the dot product of H here because I want to know what is H of del cross E. Therefore, H, take dot product of H in both the sides, on both the sides of this equation. So I'll get H of del cross E is equal to minus mu h dou h by dou t. Therefore, now I'll substitute this equation in 2. Therefore, equation 2 becomes and rewriting the equation 2 by replacing the values of h del cross E. So that becomes minus mu h minus mu h dou h by dou t minus del of E cross h is equal to sigma E square plus epsilon E dou E by dou t. Now I'll keep this term here, rest all the values of components I'll move to the right hand side, so including this minus. Therefore, rewriting the equation, reorganizing the equation, I'll get del of E cross H is equal to, okay, let me just retain minus as it is equal to epsilon E square plus sigma E dou E by dou t plus mu h dou h by dou t. Okay, now this minus, multiplying the entire equation by minus, I'll get del dot E cross h, rewrite the equation in terms of minus value now, is equal to minus sigma E square, sorry, this is minus epsilon E dou E by dou t minus mu h dou h by dou t. Now I'll try to express this in terms of energy values. See here, I can write this dou E by dou t here. Okay, so this is just an equivalent form. I'm just trying to write it here. So this dou E by dou t. Okay, this dou E by dou t I can write in terms of say half of epsilon dou E square by dou t square is equal to, okay, is equal to, can you see this, half of epsilon 2 dou E by dou t. Dou E by dou t, 2E, sorry, this is 2E dou E by dou t. So we'll get this is equal to epsilon E dou E by dou t. This is dou t, dou E by dou t. half epsilon dou E square by dou t can be written as epsilon E dou E by dou t. So I'm just trying to substitute these values here. So similarly, you can write it as half mu dou h square by dou t is equal to mu h dou h by dou t. So substitute these values here. I'll get del dot E cross h, del dot h is equal to minus sigma E square minus, so I'll replace this minus epsilon E dou E by dou t by minus half epsilon dou E square by dou t. This is not dou square E by dou t square. Remember, it is equivalent form of dou E by dou t minus half epsilon, sorry, minus half mu of mu dou h square by dou t. Now, but I want only E cross h, right? Because I'm trying to obtain the relationship for Poynting's vector or Poynting theorem in the form of E cross h. And it is a relationship between power and electric field and magnetic field. But I have del dot E cross h. So how to remove this del component? So del component can be removed by taking volume integral. Take volume integral on both the sides. Take volume integral on both the sides. It is v dv on both the sides. I will get volume integral del dot E cross h dv is equal to, I'll write this term first, minus volume integral minus half epsilon dou E square by dou t minus half mu dou h square by dou t minus epsilon E square into dv to dv. I'll just try to rewrite this equation. Volume integral is trying to reorganize the equation. Del dot E cross h is equal to, I'll take out the differential components outside, minus dou by dou t. The remaining is volume integral of half epsilon E square plus half mu h square. I'm just trying to bring it to the canonical form, dv plus, sorry, this is minus volume integral sigma E square dv. Remember this equation. All this is equation number 3. Okay, all this is equation number 3. So I want to convert this. I just want this particular term E cross h. So I'll convert this into a surface integral by taking a divergence theorem. Apply divergence theorem or take divergence on left hand side. I'll get surface integral, closed surface integral E cross H ds is equal to, now I'll write the same equation, minus dou by dou t volume integral half of epsilon E square plus half mu H square dV minus volume integral sigma E square dV. Call this as equation number 4. So now if you carefully observe this RHS of your equation number 4, see this RHS of equation number 4 signifies the power equation. See here, RHS of equation number 4 signifies power equations. Signifies what? Power equations. There's a kind of power, half mc square, I square r. So kind of, right? It's almost like similar to power equations. So in what way? So here, sigma E square is called as ohmic power. I'm just trying to concentrate here. So this sigma E square is called as ohmic power dissipation, whereas minus dou by dou t half epsilon E square is called as electrostatic energy. So this term is called as electrostatic energy. Electrostatic energy, and this term is called as magnetostatic energy. Magnetostatic. So this entire RHS signifies power equations, where sigma E square is called as ohmic power. Just make a note of discrete equations here. So this is ohmic power, and minus dou by dou t of half epsilon E square is what? So how do you explain this term? Decrease. So it is decrease. Minus is nothing but what? Decrease in what? Rate of change of, decrease in rate of change of electrostatic energy. Decrease in rate of change of electrostatic energy, and this term is minus dou by dou t half mu h square. So this is again decrease in rate of change of magnetostatic energy. Decrease in rate of change of magnetostatic energy. And now, since RHS is equal to LHS, see here what you're trying to say, this surface integral of E cross H ds is equal to what? All these are power equations, so I shall try to equate it to power. Since LHS is equal to RHS and RHS are the set of power energy equations, so now I will say P, that is power, is equal to P, that is power, is equal to surface integral, closed surface integral E cross H ds. This is called the power equation of an electromagnetic wave And yeah, obviously this is expressed in terms of watts. With respect to equation 3, if you just carefully understand, try to understand the concept of this equation 3. This equation 3 gives you the story that power leaving the volume. See here, this is the power leaving the volume, the LHS. LHS is the power leaving the volume. This is volume integral of del dot E cross H dV. So power leaving the volume is equal to what? Is equal to the difference between, I repeat, the difference between the rate of decrease of electric or electrostatic energy and magnetic energy stored within the volume is equal to the rate of change of electric energy. This is electric energy and magnetic energy within the volume and ohmic power dissipation. This is ohmic power dissipation. Ohmic power dissipation. So I repeat, with respect to equation number 3, I can call it as power leaving the volume. Final statement of Poynting's theorem. Power leaving the volume is equal to, power leaving the volume is equal to the difference between the rate of decrease, the rate of decrease of electric and magnetic energies and ohmic power dissipation and ohmic power dissipation. So here I could say P is equal to what? Surface integral E cross H ds, which is equal to volume integral of divergence. Divergence is nothing but what? Power leaving. Divergence of E cross H dV. So here I am referring to this term here. Power leaving the volume. Divergence is nothing but leaving, right? It's trying to diverge. Power is diverging, leaving a small volume. Here it is delta V. If you integrate it, it becomes a large volume here. Is equal to what? Is equal to rate of decrease of electric and magnetic energy. Is equal to rate of decrease is nothing but half, right? Half minus half dou by dou T epsilon E square plus dou by dou T minus half mu H square. So is equal to rate of decrease. Rate of decrease, this minus is nothing but decrease. Rate of decrease of electric energy and magnetic energy. So you have told difference between, right? So this is difference between, this is now ohmic power, that is sigma E square dV. Again, this is volume integral. This is volume integral here with respect to the volume. So this is rate of decrease in electric energy plus magnetic energy. So difference of electric energy plus magnetic energy minus ohmic power dissipation. Minus ohmic power dissipation with respect to the volume. With respect to the volume. So this is called as Poynting's theorem. or Poynting's vector. So basically, Poynting's theorem or Poynting's vector is the theorem or a statement which is made to establish a relationship between E cross H and the power. So it's a power relationship between the electromagnetic waves and electric field and magnetic field, and of course power dissipation. Again, it is an electric field. I hope you understood this concept. So please uh, make sure you write down these equations. We started from modified Ampere circuital law and we arrived to this power equation. This in terms of E cross H. Hope you enjoyed watching this video on Poynting's theorem and Poynting's vector. Thank you. Thank you for watching this video.